Welcome to another episode of learning. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We now discuss the solutions of the problems related to quadratic equations that have appeared in the JEE Main examination held in the January 2025 session. This is the fifth question. This question has appeared in the JEE Main exam held on 28th January 2025 in the evening shift. The given question is, let f be a function from the non-zero real numbers to the open interval minus infinity to 1 be a polynomial of degree 2. It is a polynomial function satisfying this functional equation f of x multiplied by f of 1 by x is equal to f of x plus f of 1 by x. If f of k is equal to minus 2k, then the sum of the squares of all possible values of k is, we are given 4 options. The options are here. Let's now discuss the solution of the problem in detail. We have a function from the set of non-zero real numbers into the open interval minus infinity to 1, and it is defined by a polynomial of degree 2. So for that, we let f of x be x square plus bx plus c, where a not equal to 0. If you make a is equal to 0, then it reduces to a polynomial of degree 1. But it is given to be a polynomial of degree 2, then a is not equal to 0. Right. Given f of x satisfies this functional equation, f of x into f of 1 by x is equal to f of x plus f of 1 by x. Right. Now, for f of x, you write ax square plus bx plus c multiplied by f of 1 by x. You write a by x square plus b by x plus c is equal to f of x plus f of 1 by x. Right. Multiply with this first term, a into 1 by x square, what I have written in red, plus multiply by b into b by x, then you get the blue ones. Multiply this by c, then you get the black ones. And f of x, f of 1 by x is written. Now collect the coefficients of x square plus the coefficient of x plus constant on left hand side. So also in right hand side. Right. This is what we get. On the left hand side, say AC x square, that is the coefficient of x square is AC. On the right hand side, the coefficient of x square is A. Therefore, equating the like terms, the coefficients of like terms, then you get AC is equal to A. The coefficient of x, AB plus BC must be equal to B. And the constant term, A square plus B square plus C square is equal to 2C. And the coefficient of 1 by x square, AC, is equal to A. The coefficient of 1 by x, AB plus BC, is equal to B. So this is what we get after equating the coefficients of the like terms. Right. Since a not equal to 0, AC is equal to A, cancelling A on both sides, we will get C is equal to 1. Take that C is equal to 1, substitute in the second, AB plus B is equal to B. Cancelling B, you will get AB is equal to 0. And putting C is equal to 1 here, you will get A square plus B square is equal to 1. And these are the repetitions. This is the same as first and second. Right. Now we get this one. Now this implies AB is equal to 0. A not equal to 0 will imply B is equal to 0. When B is equal to 0, A square plus B square is equal to 1 will become A square is equal to 1. Then C is equal to 1, B is equal to 0, A square is equal to 1. A square is equal to 1 will imply A is equal to plus or minus 1. So C is 1, B is 0, A is plus or minus 1. So the solution of this functional equation is f of x is 1 plus or minus x square. For A, plus or minus 1. For B, 0. For C, 1. So this is the one. Now, what happens if I take f of x is equal to 1 plus x square? And if you take f of x is equal to 1 plus x square, then what is the range of this function? The range of this function is open interval 1 to infinity. But your function f of x, your given function f, has the codomain minus infinity to 1. So this is not possible. It's a contradiction. It's not contradiction. Therefore, f of x is equal to 1 plus x square. 1 plus x square is not possible. Therefore, f of x is equal to 1 minus x square. Agreed. Agreed. We continue in the next slide. Right. We have solved and we got f of x is equal to 1 minus x square. Now go to the condition. F of k is equal to minus 2k. So given f of k is equal to minus 2k, required to find the sum of the squares of all possible values of k. Agreed. F of x is equal to 1 minus x square. For x, substitute k. F of k is equal to 1 minus k square. That will imply f of k is minus 2k is equal to 1 minus k square. And this is the quadratic equation, k square minus 2k minus 1 is equal to 0. Solving for k, we'll get k is equal to minus b plus or minus b square under the square root of b square minus 4ac by 2a. And substitute the values. Simplify, you will get the k values are 1 plus root 2 and 1 minus root 2. And the sum of the squares of all possible values of k is 1 plus root 2 whole square plus 1 minus root 2 whole square. This is a plus b whole square plus a minus b whole square is 2 times in brackets a square plus b square. That is 2 times in brackets 1 square plus root 2 square. That is 2 times in brackets 1 plus 2. That is 2 times 3. That is equal to 6. So the answer to this question is 6, and the 6 appears against option 2. Therefore, the answer to this question is option 2. That is the detailed discussion of the solution of this problem. So in this question, the examiner has given a functional equation and he combined the results with a quadratic equation. It's a good question. Let's move to the next slide. So that is the question number 6. This question has appeared in the JEE Main examination held on 28th January 2025 in the morning shift. The given question is the sum of the squares of all the roots of the equation x square plus mod of 2x minus 3 minus 4 is. We are given 4 options. Right. Let's now discuss the solution of the problem in detail. We have the given quadratic equation x square plus mod of 2x minus 3 minus 4 is equal to 0. Let's call this as the equation 1. Now, we deal the cases in 2 cases. Case A. when 2x minus 3 greater than or equal to 0. When 2x minus 3 greater than or equal to 0, x is greater than or equal to 3 by 2, and mod of 2x minus 3 is equal to 2x minus 3. So replace mod of 2x minus 3 by 2x minus 3 and write down the given equation. Right, the given equation is will become x square plus 2x minus 7 is equal to 0. Agreed? Now, is a quadratic equation. Solve for x. X is equal to minus b under the square root of b square minus 4ac by 2a. Substitute and simplify. You will get plus or minus 2 root 2 minus 1. Agreed. Agreed. Now, we reject x is equal to minus 2 root 2 minus 1. Why? It is negative. Why? In the first case, x is greater than or equal to 3 by 2. X greater than or equal to 3 by 2, it can't be negative. So therefore, that one we have rejected. So, we will get x is equal to 2 root 2 minus 1. And 2 root 2 minus 1, 2 into root 2 is 1.41 minus 1. And this is approximately 1.82, which is bigger than 3 by 2. Therefore, this is a candidate for us. Now, take the second case when 2x minus 3 is negative, when x is less than 3 by 2. Then mod of 2x minus 3 will be minus of 2x minus 3. That is minus 2x plus 3. Then the given equation will become x square minus 2x plus 3 minus 4. Simplify. You will get x square minus 2x minus 1 is equal to 0. Again a quadratic equation. Solve for x. Then we will get the values of the roots is 2 plus 2 root 2 by 2. That is 1 plus or minus root 2. Right. Right. Now here we reject 1 plus root 2. Why? 1 plus root 2 is greater than 3 by 2. 1 plus 1.14. This is 2.14, which is bigger than 3 by 2. But in this case, x is less than 3 by 2. Therefore, we reject that. Then we get x is equal to 1 minus root 2, which is a negative, definitely less than 3 by 2. Right. Right. So, this is a candidate for us. So, the sum of the squares of all the roots of this equation E is 2 root 2 minus 1 whole square plus 1 minus root 2 whole square. Now square it, simplify it, we will get a 12 minus 6 root 2. That is 6 times 2 minus root 2. This 6 times 2 minus root 2 appears against option 1. Therefore, the answer to this question is option 1. That is the detailed discussion of this simple and straightforward question. Right. We move to the next question. This is the question number 7. This question has appeared in the JEE Main exam held on 24 January 2025 in the second shift. The given question is the number of real solutions of the equation x square plus 2x plus 2 is equal to the minimum of mod of x minus 3 comma mod of x plus 2 is. And we are given 4 options. Options are here. And to work out such a problem, now we adopt the following strategy. The number of real solutions are given by the number of points of intersection of 2 curves. First curve is y is equal to x square plus 3x plus 2, which is a parabola. And the other is y is equal to minimum of mod of x minus 3, comma mod of x plus 2. So work out this problem using the geometry and algebraically doing it will lead to so many cases and it will be difficult in the examination. Therefore, we do it by geometry. So, what is this curve? What is this curve? The points of intersection of these two curves will be the number of real solutions. Right. So we straight away go to this curve. Y is equal to mod of minimum of mod of x plus 2 and mod of x minus 3. This is you know mod of x plus 2 will be a V-shaped curve with the vertex at x is equal to minus 2. Mod of x minus 3 will be a V-shaped curve, vertex at x is equal to minus 3. Right. Now, this is y is equal to x plus 2. This will be y is equal to minus x minus 2. Then both these will be y is equal to mod of x plus 2. This is y is equal to x minus 3. And this is y is equal to minus x plus 3. This is, these two put together is y is equal to mod of x minus 3. Right. Now, the whole of r square is divided into, so, right, y is equal to x plus 2, y is equal to minus x plus 3, they intersect at 1 by 2, comma 5 by 2. So, r square is now divided into sub-regions. Region, this is the first region, x less than minus 2. This is the x is equal to minus 2 straight line, and towards left is x less than minus 2. In this region, and you see this curve up to this and this curve up to this, which is a minimum. The minimum is y is equal to minus x minus 2 because it is in the upper portion. So, this is the minimum. Whenever you consider this is the minimum, is the minimum. So, minimum of mod of x minus 3 comma mod of x plus 2 is equal to minus x minus 2 when x less than minus 2. Right. The next subregion is this one. This is x is equal to 1 by 2. So, what is the region? Minus 2 less than x less than 1 by 2. In this, this is the y is equal to x plus 2 and this is y is equal to minus x minus 3. What is the minimum? The minimum is y is equal to x plus 2. So, is equal to x plus 2 when minus 2 less than x less than 1 by 2. Right. The next subregion is 1 by 2 less than x less than 3. This is x is equal to 3. So, in this subregion, and this is the curve, y is equal to x plus 2. This is the curve, y is equal to minus x plus 3. Between these two, what is the minimum? The minimum is y is equal to minus x plus 3. So, it is minus x plus 3 when 1 by 2 less than or equal to x less than 3. Continuity is there, therefore, keep the equality at one end. Now, the last one is when x greater than or equal to 3. In x is greater than or equal to 3 and between these two minimum is y is equal to x minus 3. So, is equal to x minus 3 when x greater than or equal to 3. So, that is the piecewise function y is equal to minimum of mod of x minus 3 into mod of x plus 2. This is looking like this one. This is looking like a W. We call this curve as the W curve. Right. We continue. Right. So, that's the W curve. We call this curve as the W curve. This is the piecewise definition of that function. This is the second curve. This is y is equal to minimum of mod of x minus 3 comma mod of x plus 2. Let's get into the first curve, that is y is equal to x square plus 3x plus 2. What is this? It's a parabola. It It's a polynomial equation of degree 2. Is a parabola opening upwards. Why opening upwards? The coefficient of x square is positive, therefore it opens upwards. And where it intersects x-axis. It intersects x-axis means put y is equal to 0. You will get x is equal to minus 2 and minus 1. So it intersects x-axis at minus 2 comma 0 and minus 1 comma 0. And it intersects y-axis, that is put x is equal to 2, it will be 2 comma 0. So it intersects y-axis at 0 comma 2. And observe that minus 2 comma 0, this one, and 0 comma 2, this one, they lie on y is equal to x plus 2. Y is equal to x plus 2. So the points minus 2 comma 0 and 0 comma 2 lie on y is equal to x plus 2. And now let us draw the parabola and the W curve intersect at minus 2 comma 0 and 0 comma 2. Right? So minus 2 comma 0 and 0 comma 2 is on x square plus y is equal to x square plus 3x plus 2, that is on the parabola. And these 2 points are also lying on our W curve. Therefore, the point of intersection is these 2 points. So that is the parabola coming out and intersecting at x is equal to minus 2, x is equal to minus 2 and x is equal to 0. So minus 2 comma 0 and 0 comma 2. These are the 2 points of intersection. So in how many points the number of real solutions are there for this equation? So the number of real solutions of the equation, this parabola, the x square plus 3x plus 2 is equal to minimum of mod of x minus 3 comma mod of x plus 2 is the number of points of intersection of the parabola and the W curve. That is 2. That is 2. Let's look at our options. So our answer 2 appears against option 1. Therefore, the answer to this question is option 1. And that is the detailed discussion of the solution of this problem. If you work out this problem by like this, that is geometrically, it becomes easier. Right. We move to the next question. Question number 8. Right. And this question has appeared in the JEE Main exam held on 24 January 2025 in the morning shift. The given question is the product of all rational roots of the equation x square minus 9x plus 11 whole square minus x minus 4 multiplied by x minus 5 is equal to 3 is equal to. We are given 4 options. Right. Let's now discuss the solution of the problem in detail. We are given this equation. Now, x square minus 9x plus 11 whole square minus x minus 4 multiplied by x minus 5, when multiplied you will get x square minus 9x plus 20 is equal to 3. Bring 3 to this side, to the left hand side, you will get minus 3 is equal to 0. In this, substitute x square minus 9x plus 11 t, that is substitute t for x square minus 9x plus 11. Then when x square minus 9x plus 11 is t, x square minus 9x plus 20 will be t plus 9. Right. This implies t square minus in brackets t plus 9 minus 3. That is t square minus t minus 12 is equal to 0. Factorize t minus 4 into t plus 3 is equal to 0. That is t is equal to 4 and minus 3. Now take the first case. When t is 4, what is t? X square minus 9x plus 11 is equal to 4. Simplify. X square minus 9x plus 7 is equal to 0. It's a quadratic equation. The solutions are minus b plus or minus under the square root of b square minus 4ac by 2a. And simplify. you will get 9 plus or minus under the square root of 53 by 2. Root 53 is irrational. 53 is irrational. Under the square root of 53 is irrational, and therefore we get irrational roots. Now take the next case, second case, t is equal to minus 3. This implies x square minus 9x plus 11 is equal to minus 3. Now simplify, we'll get x square minus 9x plus 14 is equal to 0. And factorization is very easy. The factors are x minus 2 into x minus 7 is equal to 0. This implies x is equal to 2 and x is equal to 7. Both are rational numbers. Right? They are integers and therefore rational numbers. And what is to be found out? The product of all rational roots of the equation. The rational roots are 2 and 7 only. These roots are not rational. Therefore, we are not considering. The product is 2 into 7. So, the product of all the rational roots of the equation is 2 into 7 is equal to 14. And our answer 14 appears against option 4. Therefore, the answer to this question is option 4. That is the detailed discussion of the solution of this problem. And the problems that I have mentioned in this video, except for that the points of intersection of that parabola and the W curve, except that the remaining questions are all very, very easy. Right. I am sure that we have yet another question, question number 9. Agreed. This question has appeared in the JEE Main exam held on 22nd January 2025 in the second shift. Right. Let alpha theta and beta theta be the distinct roots of this quadratic equation 2x square plus cos theta multiplied by x minus 1 is equal to 0, where theta belongs to the open interval 0 to 2 pi. If small m and capital M are the minimum and maximum values of alpha theta to the power of 4 plus beta theta to the power of 4, then 16 times capital M plus small m in brackets equals, we are given 4 options. Agreed. Let's now discuss the solution of the problem in detail. We are given alpha theta, beta theta are the distinct roots of this quadratic equation where theta belongs to the open interval 0 to 2 pi. Now, alpha theta plus beta theta is the sum of the roots of this quadratic equation. The sum of the roots is equal to minus the coefficient of x by the leading coefficient 2, that is minus cos theta by 2. And alpha theta beta theta is the product of the roots is equal to the constant of minus 1 by the leading coefficient 2 minus 1 by 2. So, we got alpha theta plus beta theta and alpha theta beta theta. It's not difficult to find out alpha theta to the power of 4 plus beta theta to the power of 4. Right. Now, alpha theta to the power of 4 plus beta theta to the power of 4 is equal to alpha theta square plus beta theta square whole square minus 2 times alpha theta square into beta theta square. Right. For this sums of the squares, we write alpha theta plus beta theta whole square minus 2 alpha theta beta theta, that will be alpha theta square plus beta theta square whole square minus 2 times alpha theta square beta theta square. This is equal to alpha theta plus beta theta whole square is minus cos theta by 2 whole square and this one minus 2 alpha theta beta theta. Alpha theta beta theta is minus 1 by 2. Therefore, minus 2 times of alpha theta beta theta is minus 1. Minus of minus is plus 1 whole square minus 2 into Alpha theta square multiplied by beta theta square is 1 by 2 whole square. Minus 1 by 2 whole square is 1 by 4. This is cos square theta by 4 plus 1 whole square minus 1 by 2. How do I get the maximum value? The maximum value is when cos square theta is plus 1. When cos square theta is plus 1, when this happens in the interval 0 to 2 pi, when theta is equal to pi, you will get cos theta is minus 1, whole square is plus 1 by 4. So the maximum value of this one is attained at theta is equal to pi in this interval. Capital M is maximum of this. The maximum of this value is attained at theta is equal to pi. So substitute. So you will get cos theta is minus 1 whole square is 1 by 4 plus 1 whole square minus 1 by 2. That is 25 by 16 minus 1 by 2. That is 17 by 16. Small m is the minimum value of this. When the minimum value is obtained, when cos square theta is 0. When cos square theta is 0, so cos theta will be 0 when theta is pi by 2 or 3 pi by 2. So anyway, at theta is equal to pi by 2, it attains the minimum value. The minimum value is 1 square. This is 0 plus 1 square minus 1 by 2. That is 1 minus 1 by 2 is 1 by 2. Right. Now, 16 times in brackets capital M plus small m is equal to 16 times in brackets 17 by 16, that is capital M, plus small m is 1 by 2. Simplify, you will get 16 into 25 by 16. 16 cancels, you get 25. Where is my 25? Against option 2. Right. So, the solution is 25 and which appears against option 2. Therefore, the answer to this question is option 2. That is the detailed discussion of the solution of this problem. This is also a very simple and straightforward question. Right. I am sure that you understood the solutions of all these questions. Thank you for watching my video now. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. We will certainly meet you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.